So, hey guys, today we will be talking about one of the most interesting binomial identity, okay, and the intuition behind it, right? So, the identity goes like this. It is summation of nc0 plus nc1 plus nc2 and up to ncn, which will be 2 raised to n. Okay, so let's see how we can approach this intuitionally. Okay, so if I ask you a question that you are having a pizza, one pizza, and for that you have n types of toppings. Okay, so you can choose any of them. Okay, these n are totally distinct. Okay, totally distinct toppings, and you can choose any of them to make your pizza. So, if I ask you in how many ways you can eat the pizza, number of ways to eat the pizza, right? So, the obvious answer that we can come up with is 2 raised to n, right? Because what can I say? This is my topping number 1, 2, 3, and so on. So, this is my topping number n. So, for one, I am having two choices, either I will eat or I won't. For 2, I am having two choices. Either I will eat or I won't. For 3, similarly, I am having two choices. And so on. So I am having two choices for nth also. Right? And we know that the rule of basic multiplication, fundamental multiplication, which we saw in our earlier videos, the answer will be 2 raised to n. Now, you tell me, in this 2 raised to n, we cover all the cases. The cases were there were zero toppings, or there will be one topping, or there will be two topping, so and so there will be n toppings. Now you must understood this, that all of these cases, this case 1, 2, 3, and up to n plus 1th case, all of them are disjoint because the number of toppings are themselves very different. So there is no question about the intersection, right? Now, what can I write the number of ways for which there I am taking zero toppings? I can write that NC0 because I am not taking at all any topping. How many pizzas will be there for which I am having exactly one topping? I can say NC1, right? Because out of n things, I am choosing one of the type of topping for my pizza, right? Now, how many pizzas will be there having exactly two toppings? Again, here I can say there will be NC2 choices to make such a pizzas, so on so. If I want to take all the n toppings, there will be ncn ways, right? Because out of n, I am taking all the n. Now, you were agreed with me that this 2 raised to n can be broke up like this. Number of pizzas having 0 toppings plus exactly 1 topping plus exactly 2 up to n. Now, the cases were found to be these many cases for each of them, right? There were these many combinations for the first case, for the second case, for the third case, and for the last case. So their summation must be equal. Now, okay, this was fine intuitionally. Now let's see it algebraically. Okay, algebraically, what can I say? We know that x plus y raised to n can be written as nc0 x to the power n, nc1 x to the power n minus 1 and y to the power 1. Okay, nc2 x to the power n minus 2 and y to the power 2, so on and so forth. ncn, out of n I choose all the n, so x to the power 0 and y to the power n. Now if you simply put x is equals to y is equals to 1, what you will find is 2 to the power n is equals to nc0 plus nc1 plus nc2, so on so forth till ncn. So right, we prove this algebraically, right, which we learned in our 11th or 12th, and we prove this intuitionally, right? So as we can see, both are the same things, just it's the way how we break the things, right? Here we can see that this 2 raised to n covers all the possibilities, having no topping at all to the having n toppings, right? From zero toppings to all the n toppings. And how we break the case? We break the each and every cases based upon how many toppings we are having. zero toppings we can have, or one or two, and so on and so forth. And we found out the number of combination for each of the case, and as those were disjoint, we can use the simple principle of addition, right? This plus sign over here, and it worked quite a well, so that we got that answer, right? I hope this have cleared the intuition behind this logic. If you have any doubt, please feel free to ask. Okay, and take care of your time and take care of yourself. May the force be with you. Okay.